Hello students, I hope you all are fine. Students, as you know that our revision is going on. Okay, so in that I have given homework to you for revising unit 12. Yes, so student, today we will do some important questions of unit 8, that is the aldehyde, ketone and carboxylic acid, and some questions belongs to previous year questions of CBSE also, and some more important questions are there. Okay, so students, today we will go with some important questions of unit 8, aldehyde, ketones and carboxylic acid. Let's see about that. So students, our first question is, write the structure of 3-oxopentanal. 3-oxopentanal. Students, when you write the structure, one question you will get from structure either may be asked from alcohol phenol or from aldehyde ketone, from amine, from haloalkane, haloarine. Means one question in your board exam definitely you will get. So you should know how to write structure. So how can you write students? Means first you will see word root. First you will see word root during writing the structure of any compound. So word root is pentanal. Pent means 5 carbons are there. Okay, you all know very well. So you will make 5 carbons. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Yes, at least one bond these carbons are making between them. Then you will see functional groups and sufficients. Okay, pentanal. Al means aldehyde. Al we use for aldehyde. And students, aldehyde group is CHO group. CHO group. Aldehyde group is CHO group. But students, CHO group, okay, that is also including in word root. Okay, it also include in word root. So CHO group differently we will not use like this. We will not write like this. What will we do? This one only, CHO. So 1, 2, 3, 4, 5. Okay. Then student, we will see about the substituents. So here substituent is 3-oxo. Oxo means bond with oxygen. Oxo means bond with oxygen. So at 3 position, 1, 2, 3. Okay. First, you will see word root. You will write same number of carbons there. Then you will write functional group. If your functional group is aldehyde or carboxylic acid group there, so carbon of group are also included in parent chain. Okay. After that, you will see substituents there. And after doing that, you will complete valency. For carbon, you know very well, one carbon can form 4 bonds. It is tetracovalent. Okay, so you will fulfill all 4 bonds of the carbon. So now this carbon, 1 bond it has formed. So now 3 more bonds. Here it has formed 1 and 1, 2. So 2 more bonds you will make with hydrogen. Then it has formed already 1, 2, 3, 4. So you need not to give any hydrogen. Now 1 and 1, 2. So 2 hydrogen you will provide. So student, this one is the structure for 3-oxopentanal. This is the 3-oxopentanal. This is structure for 3-oxopentanal. I hope this structure is clear to all students. Is it clear? Yes. So now move to the next one question. Our next one question also belongs to structure, students. Okay, now you will try to yourself. Okay, but I will also explain. Your question is, write the structural formula of 1 phenyl pentane 1 on pentane. So again, you all know very well. First you will see about word roots. So pentane means 5 carbons are there. You will write 5 carbons. 1, 2, 3, 4, 5. Okay. 1 on. At one position on. On functional group which one? On. Mean that is the suffix of ketonic group. That is the suffix for ketonic group. Okay. So at one position ketone is there. Okay. You have written. Now you will see about substituents. 1 phenyl. At one position phenyl. Phenyl group is C6H5. Phenyl group is C6H5. C6H5. So at one position C6H5 also. C6H5. Okay. Now you will fulfill all the valency of carbons. So now 1 bond it has formed, so 3 hydrogen. Now 1 and 1 2, so 2 hydrogen with this. 1 and 1 2 bond it has formed, you will provide 2 hydrogen. 1 and 1 2 already, 2 hydrogen you will provide. Now 1 1 2 3 4 completed it is also. So student, this one is the structure for 1 phenyl pentane 1 on. I hope you all are able to write about structure of any element now. Okay students, wait a minute. So student, there was some light issue, that's why sorry for inconvenience. So now we will move to the next one question. Okay, our next one question is, arrange the following compounds in an increasing order of their reactivity in nucleophilic addition reaction. Nucleophilic addition reaction. You all know very well students, carbonyl compounds. Carbonyl compounds. Carbonyl compounds. Carbonyl compounds means aldehydes, ketones, carboxylic acids, amides, acetyl chlorides, all these means in which C double bond O group is there. Those compounds are known as the carbonyl compounds. Those compounds are known as the carbonyl compounds. And carbonyl compound, students, they show nucleophilic substitution reaction. Why do they show? Why? Because this carbon and oxygen bond, this one is polar. Because oxygen is more negative as compared to the carbon, so it will attract electron towards itself. Due to its more electronegativity, this oxygen is more electronegative as compared to the, this is more electronegative as compared to the carbon. And availability of electron, availability of pi electrons also there, so easily it can take electrons. Then what will happen, student? What will happen? Deficiency will create at this carbon. So one nucleophile will support this one carbon. Okay, one nucleophile will support this carbon. Okay, and finally what can happen here? Nucleophilic addition reaction can take place. Okay, so student, this nucleophilic aldehyde show more. Aldehyde show more as compared to the aldehydes reactivity. Aldehydes reactivity is more as compared to the ketones. As compared to the ketones. Why is it? Because in case of ketone, two bulky groups are there, two R groups are there. So hindrance will take place. So what will happen? Hindrance will take place due to presence of these two bulky groups. So hindrance will take place, and due to hindrance, reactivity decrease. Due to hindrance, reactivity will decrease. So students, first thing you will see in which hindrance increases, so reactivity decreases in that. Means if size or bulky group increases, then what will happen? Then students, reactivity decrease. Okay, and aldehydes are more reactive towards nucleophilic addition reaction as compared to the ketone. Okay, so on behalf of these points you will reply. Now we are having ethanol. We are having ethanol, propanol, okay, propanone, and butanone. So we need to tell about increasing order. So student, which one having the smallest size? Okay, that will be the most reactive. And which one having more number of them? So butanone. Butanone means that group. Now 4 carbon. One is CS3 and CS2, CS3. This one, 1, 2, 3, 4. This is butanone. Propanone means acetone. That is propanone. Then propanol. Propanol means CH3 CH2 CHO. Ethanol CH3 CHO. So which one has greatest size there and more bulky groups are there? So student, you can see this one having more bulky groups. So its reactivity less. After that it has two alkyl group. So at second number its reactivity, then this third one, and at last this one is highly reactive. This one is highly reactive. So what will be the increasing order for the reactivity? What will be the increasing order? This has least, it has maximum, after that this one and this. So we have written decreasing order. We have written decreasing order. If you will write increasing order, then how will you write? How will you write? You will write butanone, propanone, propanol, and at last ethanol there. Okay, so student, if hindrance increases, size increases, number of bulky group increases, then reactivity will decrease towards nucleophilic addition reaction. I hope this question also clear to you. Now our next one question. Our next one question is give a chemical test to distinguish between ethanol and propanol. Means how can you distinguish? How can you differentiate between propanol and ethanol? First you will write about structure. Ethanol. Ethane means 2 carbon. Okay. So ethanol CH3 CHO. Okay. This is ethanol, student. This is the ethanol. This is ethanol. Okay. After that propanol. After that propanol. Prop means 3 carbon. 1, 2, 3. This one is the propanol. Okay. So students, how can you distinguish? How can you tell if you have any compound and you need to detect about that? You need to tell either it is ethanol or it is propanol. So how can you tell about that? Okay. So students, CH3CHO. Yes. This is clue. We have CH3COH. This group will tell us. Remember about test? Not. Iodoform test. Iodoform test. Iodoform test. Iodoform test, students. If you have this group CH3CO, if CH3CO group or CH3 or CH3CHOH group you are having now. If in any compound you see these two groups, either this one or this one, means they are giving iodoform test, otherwise not. If either methoxy, okay, so either this one or this one, means if methyl ketone, not methoxy, methyl ketone, CH3CO, either this one or this one, these groups are present, then they will show iodoform test, otherwise not. Then students, you can see ethanol. I can write like this. So student, it is having methyl ketone group. Methyl ketone. Okay. So it gives us iodoform test. But here, if you will write it, so how can you open? Write open structure. CH3, CH2, COH. So no methyl ketone group present here. So student, that's why. So student, that's why it do not show. It do not give the iodoform test. It do not give iodoform test. So by iodoform test, we can distinguish between ethanol and propanol. Now, what is iodoform test? Let's see. Actually, student, what will happen? If you are having either aldehyde or ketone, any, okay, but this group, CH3CO group must be there, okay, or either this or this, CHOH, or this group. Okay, so these group must be present there. If these groups are present now, and if you react with iodine and NaOH in presence with iodine in presence of NaOH, okay, then students, actually what will happen? Iodoform will form. Other halogen you can also take. Then if you are having chlorine, then you will get chloroform. If you will have bromine, then you will get bromoform. But they are not giving colored PPT. Okay, so that's why you can't identify. Okay, that's why we are using iodine, because iodine giving us yellow PPT. Okay, and they are clearly visible. Okay, so students, if either this group or this group present in any compound, then it can perform iodoform test. Otherwise not. Okay, so in ethanol, this group is present there, so it will give iodoform test, but propanol do not give iodoform test. So both of them, between ethanol and propanol, we can distinguish with help of the iodoform test. I hope this question also clear to all the students. Now next one, students, our next one question is, which of following compound is most reactive towards nucleophilic addition reaction? Nucleophilic addition reaction, already I told you, but if more steric hindrance is there, then it will be less reactive. If steric hindrance steric hindrance inversely proportional. Steric hindrance inversely proportional to the reactivity. Steric hindrance inversely proportional to the reactivity towards nucleophilic addition reaction. So see here, already bulky groups are present here, so these are less reactive. In between this one and this, it has two bulky group, but it has one hydrogen. So this one has least steric hindrance. If least steric hindrance it is having, so it is most reactive towards nucleophilic addition reaction. Okay, you will see hindrance. Hindrance means if any cloudiness is there, then definitely it will hinder the process, and if it will hinder the process, then the activity will decrease there. Okay, so students, means where small size, less crowdness is there, that will be more reactive. Okay, so between aldehyde and ketone, you know very well, aldehyde is more reactive, so you will go with them. Now this has biggest size, so this one is the proper option, best option. So option A, you will go with option A. I hope this question also clear to you. Now students, our next question is, Cannizzaro reaction is not given by. Cannizzaro reaction. What is the Cannizzaro reaction? It is also known as disproportionation reaction. Means in which oxidation as well as reduction both take place simultaneously. Simultaneously. Both take place simultaneously. Okay, students. So one thing, this reaction will take place when no alpha hydrogen is present. No alpha hydrogen is present in any compound. That carbonyl compound will give this reaction, Cannizzaro reaction. And this reaction takes place in presence of the concentrated basic medium. Concentrated NaOH we will take, or KOH. Concentration basic medium we will take. Okay, so student, best point for this reaction means alpha hydrogen must not be present there. Must not. I am using word not. Alpha hydrogen must not be present in compound. Then it will show the Cannizzaro reaction, otherwise not. Okay, so see in which alpha hydrogens are not present, but it is not. It is asking about not given. He is not asking about that who is giving Cannizzaro reaction. Who will give Cannizzaro reaction in which alpha hydrogens are not present, that compound will give, that carbonyl compound will give the Cannizzaro reaction. Yes or not? But if alpha hydrogens are present, there, then students, it do not show the Cannizzaro reaction. It show aldol condensation. So now see, alpha carbon means the carbon to which group is attached. So CHO group, aldehyde group is attached to this carbon. This carbon can form 4 bonds. So one bond it is forming with this, one with this carbon, one with this carbon, one with this carbon. Already 4 bond it has formed. So here alpha hydrogens 0. Alpha hydrogens 0. No alpha hydrogens here. So it will show Cannizzaro reaction. Here HCHO. Okay, so student, here this one is the group. So no alpha carbon is there. If no alpha carbon means no alpha hydrogen. No alpha hydrogen here. So if no alpha hydrogen present there, so it also show the Cannizzaro reaction. Here this carbon is alpha carbon because group is attached to this one. So it is making 1 bond with this group, 1 bond with this carbon, and 2 bond with this carbon, making double bond now. So no alpha hydrogen. Here also 0 alpha hydrogen. Okay, now CH3CHO. CH3CHO we are having. Now we will see about this also. CH3COH. Now say student, to this carbon, this group is attached. So this is alpha carbon, and to this carbon 3 hydrogens are present. So these 3 alpha hydrogens. So students, this acetaldehyde group, this acetaldehyde compound, this one, it have the alpha hydrogen, and in which alpha hydrogens are there, that compound that aldehyde do not show the Cannizzaro reaction. Okay, so here right option will be the D option, because in this compound alpha hydrogens are present there. That's why it is not showing, that's why it is not giving Cannizzaro reaction. Okay, so I hope student this question is clear to you. If alpha hydrogens are present there, that compound, that aldehyde or ketone will show the aldol condensation reaction, and if alpha hydrogens are not present there, then it will show Cannizzaro reaction. If alpha hydrogens are not present, then it will show the Cannizzaro reaction. So in Cannizzaro reaction, you will see about alpha hydrogens. If any compound not having alpha hydrogen, so that compound will show the Cannizzaro reaction. Okay, and this reaction is disproportionation reaction. Here oxidation reduction both take place simultaneously. Okay, so for example, if I am having, this, because you know very well formaldehyde having no alpha hydrogen, so definitely it will show. Okay, if you are having concentrated as NaOH, then it show disproportionation reaction, means its oxidation as well as reduction take place. You know very well, students, by oxidation aldehydes give carboxylic acid group, so it will give us carboxylate ion plus. By reduction aldehyde gives us alcohol, so it gives us alcohol also. Okay, that's why it is known as the disproportionation reaction also, and this is one example for Cannizzaro reaction. And you can see no alpha hydrogen present here, that's why it is showing this. No alpha hydrogen present here, that's why it is showing Cannizzaro reaction. So I hope that question also clear to all the students. Now students, our next question. Our next question is, propine 40% of H2SO4, 1% of HgSO4, okay. It will form A, then isomerization will take place, then it gives us acetone. Structure of A you will tell, and type of isomerization, means which type of isomerization take place there in this reaction. So let's write the reaction. Students, we are having propine, CH3, C triple bond CH. Okay. When it react with 40% of sulfuric acid, 40%. 40% means if total 100 ml we are having, then 40 ml of H2SO4 and 60 of water there. Okay. Then student, what will happen? Here we are having Hg2 positive. What will happen? Here student, addition of water take place. Addition of water take place, and it will follow Markovnikov's rule. Markovnikov's rule. What do you mean by Markovnikov's rule? Means more you will add water. So in water H positive, OH negative. According to Markovnikov's rule, more electronegative element will goes to that unsaturated carbon which has lesser number of the hydrogen. So here this one has one hydrogen and it do not have any hydrogen. Okay, so that's why students, OH group will goes with this. OH group will goes with this. So CH3 OH group, it has lesser number of the hydrogen, so OH group will goes. OH group is negatively part of this, so it will goes with this. Now double bond, and hydrogen will goes to next one carbon, to other carbon. So this one is A. This one is A. After that, what will happen, students? After that, what will happen? Tautomerization take place. Tautomerization. Tautomerization means 1,3 shifting. Hydride shift or methyl shift. 1,3 hydride shift or 1,3 methyl shift is known as the tautomerization. Actually, what will happen, students? This is our OH group now. This oxygen is more negative. Okay, so if this oxygen is more negative, so it will attract electron towards itself. This bond will shift here. If this bond will shift here, then this carbon can make maximum 4 bonds. So this will shift here. So finally what will happen? CH3. See, this bond is shifting here. So carbon, double bond oxygen. From here we get H positive. Okay. Then this bond shifting here. So now single bond here only. Because it is taking electron. Then what should be there? Negative charge should be with this. So this H positive will make bond with this negative and we get CH3. So finally we get acetone. Finally we get acetone. So students, our A compound is this compound, CH3, COH, double bond, CH2. You can see, you can check name about that because here name is given. So how will you check? Give numbering to this. 1, 2, 3. Prop 1, 2, 2 all, 1 in. But first we write primary suffix, then secondary suffix. Your primary suffix is in, in. For double bond you will use in. So prop 1 in, then you will use secondary suffix, functional group. Prop 1 in 2 all. Prop 1 in 2 all. Okay, prop 1 in 2 all. So, and your isomerism is tautomerism. Any option is given this type. Prop 1 in 2 all and tautomerization. This option metamerism. No, metamerism is not there. So you can't go with this option. Tautomerism, yes. Prop 1 in 1 all. No, 1 all is not there. 2 all. You are getting 2 all. So this one also not right option. Prop 2 in 2 all. No, 2 in is not there. In is 1. So you can't, and geometrical isomer also not there. Then prop 1 in 2 all, tautomerism. Yes, D option is correct option. So student, you will go with option D. I hope this question also clear to you. If your all concepts are clear, na student, then organic is very easy. Okay, so you need to understand about the concept. So here your option D is the correct option. Now move to next one question. I think this one is last question, students. Which of the reaction below can result in ketones? Okay. Which one of following reaction can give ketone? Oxidation of primary alcohol. You all know very well. Oxidation of primary alcohol. Primary alcohol means if this group is there. And this group by oxidation convert into CHO. Okay. So they give us aldehyde. They give us aldehyde, not ketone. So you can't go with this option. This one is not correct option. Oxidation of secondary alcohol. Yes. Oxidation of secondary alcohol. Secondary alcohol convert into ketone. Yes. Secondary alcohol oxidation gives us ketone. So this one is the right option. Let's check the next one also. Dehydrogenation of tertiary alcohol. No. Dehydrogen of tertiary alcohol gives us alkene. Dehydrogenation of primary alcohol. It also gives us aldehyde. Okay. So only this one. Oxidation of secondary alcohol gives us ketone. So option B is the correct option for this. Okay. Let's see next one question. Yes, some more questions are also there, students. The Rosemont reaction can produce which of the following carbonyl compound? What is the Rosemont reaction? Rosemont reaction. When you have benzoyl chloride, okay, you react with PdBaSO4. Okay, then what will happen? You will get benzaldehyde. So Rosenmund reaction gives us benzaldehyde. Benzaldehyde given in option. Yes, in option B. In option B. So option B is the correct option for this. Option B is correct option for this. Then students, which of following substance is least water soluble? Least water soluble. Students, solubility. Solubility in water depending on two things. One thing which is polar, because water is polar and like dissolve in like. So polar will dissolve in polar. So water can dissolve polar objects in it. Oh, sorry, polar compounds in it. Okay. So which one? Second thing, if number of carbon atom increases, number of carbon atom increases, then solubility decreases. Okay, so solubility inversely proportional to number of carbon atoms. Why? Because if number of carbon atoms increases there, na students, then hydrophobic part increases. Hydrophobic part. Phobic part means which have phobia, phobia from water. Okay, so hydrophobic part increases. So you will see in which more number of carbons are there, that will be less soluble. Methanol 1 carbon here, pentanol 5 carbons, propanol 3 carbons, ethanol 2 carbon. It has more number, so here hydrophobic part is more. Okay, there are two parts, hydrophilic and hydrophobic. Okay, so if hydrophobic part increases, that's why solubility decreases. So you will go with option B. Option B is the right option for this question. Okay, so student, these 10 questions we have discussed today, and today you will solve all the questions in your fair notebook. Okay, so thank you, have a nice day.